An important, simple concept to understand when we're looking at programming, whether that be in Python or Java or really any language, is an algorithm. Now, an algorithm is a concept. It's not a particular thing within programming, it's a larger concept. When you look into math and stuff, there is a math term related to it, and there's a concept related to it, and that can make people sort of fear the term of algorithm. But at its base, an algorithm is not a scary concept. It's not a hard concept. It's actually something that we use every day. So all an algorithm really is a set of instructions with an intended result. So like getting ready in the morning is an algorithm. Making a peanut butter sandwich is an algorithm. Writing your name on a piece of paper is an algorithm. And in fact, some of them have multiple algorithms within them. So if you're writing your name, that itself is an algorithm, but inside that are additional algorithms. Like each individual letter is its own algorithm. How to write a W is an algorithm. How to write an E is an algorithm. How to write a B is an algorithm. Then putting all those letters together into a single word or a name is an algorithm around those individual algorithms. So you can have multiple levels of this as well. And when we talk about algorithms, it's normally a good idea to talk about decomposition as well. And decomposition is not a hard concept either. It's decomposing, it's breaking down that algorithm into more simple steps. So if I'm trying to write the word web, then breaking that down into, individually a W, an E, and a B, and even those more individually, instead of a W, a diagonal line that goes from top left to bottom right and then back upward, like breaking that down even simpler is the concept of decomposition. So if I wanted to, comforting the little goose here who seems to be staring at us a little awkwardly, could be an algorithm. So it might be, first I'm going to open Safari, and maybe I'll find a hand icon, and we'll just go with this one right here. So now we have a hand icon, so that could be, a couple steps there. So open Safari, type in hand icon, find the appropriate hand icon, drag it to your desktop, grab the hand icon, and very nicely and calmly pet the goose. That could be an algorithm. Now, of course, that's silly and a little ridiculous, but you get the idea. Anything is an algorithm as long as there's a series of steps, even if they're very simple, with an intended result. Now, that being said, there can be some issues in there. You might have an intended result and you might think your steps lead up to that, but they might not. They might end up resulting in something else. If you're programming, the program might break, you might run into an error, you mistyped something, but you also might have a different issue where your program worked, but the result itself wasn't what you desired. And, those are bugs that you then try to figure out how to fix them. When we talk about programming, we talk about algorithms, there are some people that think that the two are always associated with one another. And programs are associated with algorithms, yes, but that doesn't necessarily mean that all algorithms are associated with programs. So a program is a step-by-step set of directions telling your computer to do something, whereas an algorithm is just a set of instructions for something to do something. So like a program is an algorithm, but an algorithm might not be a program. It's sort of like a chihuahua is a dog, but not all dogs are chihuahuas, right? So it's like one contains the other, but it also could have other things too, right? So if you have a dog, it might be a chihuahua, it could be a German Shepherd, it could be a Corgi, it could be a Blue Heeler, it could be a lot of things. An algorithm is the same way. An algorithm could be a computer program, but it could be just teaching your younger sibling how to make a bowl of cereal. Now, all that being said, that doesn't mean that all algorithms are equal. Some algorithms may be better than others. So just to use an antiquated example, let's say that I'm teaching someone how to use a phone book, or a directory, or something where you're looking up phone numbers, right? I could tell the person to just start on the very first page and check and see, is that the name you're looking for, yes or no? And if it's not, then move on to the next name, and then on to the next name, and etc. And just go through the whole phone book until you find the name you're looking for. Now, will that work? Assuming the name is in the phone book, then yes, it should work, but it might take a really long time. However, I could also design a different algorithm where instead of saying, like, check the first name, instead, like, let's open the phone book to the middle, and is that the name you're looking for? Now, chances are it's not going to be, but then I could say, like, hey, does the name you're looking for, like, alphabetically, let's say you're looking for the name Williams, does the name Williams come before or after the name you're currently looking on? And if you're looking in the middle of the book, you're probably in, like, the H's or something, depending on which region you live in. And of course, you'd say after. So then we say, like, let's look at the back half of the book and forget the first half of the book and split that in the middle. And we could kind of keep doing that. Now, if I know you're looking for Williams, I could just say open to the W's. But what if I don't know that? Right? So I could say, you know, open the book to about 75% of the way through. So you're in, like, the last 3 quarters and check. Did you find the name you're looking for? If not, is Williams higher in the alphabet or lower in the alphabet? And we could keep going there until we finally hit Williams. Now, of course, you know, depending on how you're looking at this, I could also say, like, flip to the section that matches the first letter in the last name that you're looking for. So there's multiple ways that we could design an algorithm to try to get to our intended result. And even if all the different ways that we think of all reach that same result, some algorithms may still be better than others based on how good of a job they do and how efficient they are. I hope that helps you kind of wrap your head around the idea of an algorithm and understand that you use them all the time and they're not scary.